Good evening, guys. Let us start today's session. So, in our last session, we discussed about logical NOT operator. Then, under the special operator, we learned what about the working principle of the comma operator, how it works. Now, today, we are going to explore another special operator that is known as sizeof operator. Very important. The sizeof operator is, let us assume I'm giving you a code where you have to predict what will be the output of the code here. Suppose I take a variable here, int a, and then int I is equal to 1, or say, let us assume the same line, I is equal to 1. Here I also have another variable b. Now b is equal to 10 into I plus sizeof operator hyphen minus minus I plus 4 minus 10 by I. And lastly, we're printing the result of b. B is equal to %d. B. We want to get the output. Now, before I tell you what output we should get, we must have the awareness of size of operators in C programming language. Now, there are so many operators are there. Size of operators comes under the category of special operator. It comes under the category of special operator. See here, size of is a single word. There is no space between size and of. No, size of is a single word. So the very first point with respect to size of operator is, it is a special operator. Is a special operator. Next and after that, it is the only compile time operator. So it is a compile time operator. Compile time operator means what, guys? This is the only operator which works at the compilation time. Most of the operators like plus, minus, multiplication, division, modular division, greater than, less than, logical or logical not, they works at runtime. When the program is in execution mode, at that time those operators works. This is the only operator which works at the compilation time. Not only that, it is a unary operator. It is an unary operator. Unary operator means what? Unary operator means what? The operator which works on one operand. Unary operator means the operator which works on single operand or one operand. That is called unary operator. Suppose, for example, if you write a minus b, here minus is working on how many operands? 2 operands. Operands means data, guys. Operand means data. So we can say that here minus is acting. Here minus is acting as binary operator, guys. Why binary operator? Because it works on more than one operand. That's why it's called binary operator. But when you say minus x, here minus is working on how many operands? One operator. So that means here minus is working as unary operator. So we have some operators who can play the role of binary operator and who can play the role of unary operator also. Just we have to check that on how many operands it is acting, right? Whenever we say x plus plus or we say minus minus y, they are working on how many operands? One operands, and hence unary operator. Minus minus pre-decrement works on how many operand? One operand, and hence is a unary operator. Similar to that, size of operator works on single operand. That's why size of operator is known as unary operator also. So three special word we have used here. Special word, compile time operator, and unary operator. Now, what about the working principle? What it gives? Working principle of the size of operator. First of all, the size of operator is giving the size in terms of byte when operand is a data type. That means when size of operator is used with the data types such as int, float, char, it returns the amount of memory. Allocated to that data type. It returns the amount of memory allocated to that data type. Suppose, for example, let us assume you are not having the awareness of size of integer. Then what you will do? Copy here, later I will bring into the picture. Suppose you are writing here printf %d size of int. Similarly, printf %d size of float. We can have so many things now. Long, double, long, double, so many things. Here it is, let it be long. Let it be, this one is long. Say this is float. Let it be double. Next, I'm taking one char. Here it is, say size of long float, long double. Here I'm writing size of int is equal to colon, here /n size of long. Same way, /n size of float. Here new line I require /n size of double. Here /n size of char. Here /n size of long double. Execute, compile and run. So one bracket is missing here. Execute, compile and run. Now no error, no warning. Now you see what size of operator is giving me. Size of the data type. It's simply returning the amount of memory that is allocated to the data type, to the particular data type. What is the amount of memory that is allocated to int data type? 4. But what is the unit, sir? What is the unit? 4 bytes. %d bytes. Here also bytes. Here also bytes. And here also bytes. Execute, compile and run. See this. 1 minute. Close this. Yeah. Size of integer 4 bytes. Long 4 bytes. Float 4 bytes. Double 8 bytes. Character 1 bytes. Long double 16 bytes. So moral of the story is what? Whenever we are talking about size of operator, it returns. Returns means what, guys? Returns means it gives. What it gives? Size of the operands, size of the data types in terms of the bytes. In terms of the bytes. So this is one of the application or where the size of operator is used. This is one such example. Except this, where else size of operator can be used? Suppose, for example, and another important note here is that though we are getting here size of integer is 4 bytes, actually it is machine dependent. Machine to machine, it may give you different value, that you must have to be aware of the fact that it is having a machine dependent behavior. Next, here size of operator taking the data type and giving you the size. That means here it is the size of operator. Instead of taking any operand, here it is considering data type. That means data type as operand. So case 1 is when operand is a data type. When operand is a data type. Case number 2 is, let us assume, when operand is a not a data type, but operand is an expression. Operand is an expression. Operand is an expression. In that case, what is the behavior of the size of operator? Listen, when size of operator is used with an expression, it returns means what, guys? Returns means it is giving to you. That is called returns here. It returns the size of the expression. It returns the size of the expression. How? What it means, sir? Suppose, for example, you are having a code here, int main, and you have taken one integer variable here, int a is equal to 10. And here you are taking one double variable, double d is equal to 12.34. Double d is equal to 12.34. Now here you are writing printf. Say, for example, you are writing percentile d, and then you are writing size of a plus d. Now you will get the clarity why it is called compile time operator rather than runtime operator. Observe very carefully. Let us assume this is our code. So this is a C program. Let us assume the name of the C program is test.c. Now what will happen? This code will be given to compiler. This code will be given to compiler. Compiler will take this code, and now what compiler will do? It will create, this is, let us assume, high level language. Some people consider it as a high level language. Some people consider it as a middle level language, whatever. Now compiler will convert it into machine level language. Compiler will convert it into machine level language. Machine level language means the language using zeros and ones. That is nothing but considered as a machine level language. Okay. And here the file that will be created is having an extension of test.obj. Test.obj. This file is having the code written using zeros and ones. Now execution have not started yet, just compilation happened. At the phase of compilation phase, what is the role of compiler? Compiler role is to check in your program any syntactical mistake is there or not, whether programmer have made any syntactical error or not. while writing the code. That is called syntactical mistake, whether programmer is following the rules or not. If you are not following the rules and regulations, the guidelines, making syntactical mistake, compilation error will come. If no compilation error is there, now compiler is going to convert your source code from high level language to the machine level language. Now exactly at this phase, means not runtime, sir, not execution, exactly at this phase, means while the conversation happening, high level to machine level language conversation is happening, exactly at the same time, exactly at this time, what will happen is that the size of operator will come into the picture and he will work. Size of operator will come into the picture and he will work. How he will work, sir? Observe here. A is what type? Int type. D is what type? Double type. Between int and double, who occupies more memory? Already we know that. As per our previous example output, double occupies more memory, sir. 8 byte. Integer occupies less memory compared to that double, sir. 4 byte. Size of operator will decide between these two who occupies more memory. Between these two, who occupies more memory? D occupies more memory. What is that size? 8. Now size of operator will return here a value like 8. That means your printf statement will now look like this, guys. Your printf statement will now simply looks like this. Printf %d8. It will simply look like this. Now when execution will start, when we go for a runtime execution, when your program will be executing, what will happen? He will see this code. Okay, int a is equal to 10, no problem. D is equal to 12.34, no problem. Printf, he is unable to see this code, guys. He will see this code. Printf %d d8. Then what will be printed, sir? 8 will be printed. Let us verify it whether truly these things are happening or not. Say for example, let me copy this portion of the code. I copy paste it. Execute. Achha, before that, let me copy this output. This is having a meaningful. 1 minute. This output is meaningful to us. So for our future references, let us have this value. Okay. Now let us compile and execute this code. Execute, compile and run. Achha, this part is not under comment line. Let it be make under comment line. Execute, compile and run. See here what output you are getting. Do you think that this addition will take place? No. Why? Because when the program will start execution, at that time, this A plus D is not anymore visible, guys. This is not anymore visible because at the compilation time, this part worked, sir. Compilation time, this part worked. And as per the highest data type size, the value is returned here. So at the execution time, my code is not going to see that A plus D. It is only going to see the highest data type size here. So when sizeof is used with the expression, it returns the size of the expression in terms of the highest data type. In terms of the highest data type, it returns the size of the expression in terms of the highest sized data type, in terms of the highest sized data type. That is why with respect to this, your output will come as 8. Now let us take the example with which I started today's session. Let us take this one. Now you will find it easy to give the answer. See here. Go for it, guys. Anyone there who can tell me the answer of this now from this discussion? Observe the code carefully. Apply the rules, whatever you have learned with respect to size of operator, and try to give the answer. Tell me, students, what will be the answer for this one? Very simple. Again, when compilation will occur, size of operator will come into the picture. What you will do? This line at the time of compilation, this line at the time of compilation will become what? This line at the time of compilation will become what? Is equal to 10 into I plus this size of hyphen I at the compilation time, guys. Compilation time never minus is going to work. Compilation time never minus is going to work, right? So at the compilation time, it will check the data type of the I. I is what type? Int type. Int type means it is going to return here 4. Int type means we have seen that in the current compiler, integer size is 4 bytes. I said already that it varies from machine to machine. Then hyphen 10 by I. What is I value? 1 value. What is the I value? 1 value. Sir, why it is 1 value? Because the reason is that this will work at runtime. Currently, I am in the compilation time only, sir. This minus y, minus I will be decremented at runtime, not at compilation time. Currently, I am at the compilation time means what? Minus has not executed yet. So I will have this original value. Now you check this. Precedence associativity will come into picture, guys. 10 into I is 1. So that means it is 10 plus 4 minus 10 by 1. 10 by 1. 10 by 1 is what? 10 by 1 is arekta 4, no? Plus where is that? 10 into I. 10 into I plus another 4 is there. Yes, this plus 4 is there. This plus 4 is there, right? Plus 4, this 4. Yes. So now 10 into I means 10 into 1, that is 10 plus 4, again plus 4 minus 10 by 1. Quotient, guys, we are dividing 10 with 1. That means what you will get? 10 only, na, sir? Now what will happen? Don't say, sir, plus minus 10 will be cancelled out. You can do that in that fashion, but to be technically sound, it will something like precedence and associativity rule. 14 plus 4, 18, 18 minus 10. The answer should be 8. That should be the answer. Now let's see. Execute, compile and run. Perfect. No? The v value is printing as 8. Such a beautiful operator. So much internal story is there with respect to this. What is called? Another special operator that is known as size of operator. I hope you got complete clarity with respect to the working principle of size of operator, where it is applicable, how it looks like, as well as when it works. Yes, guys. So let us take one more example with respect to the size of operator. Say, just I'm declaring few variables here. IJK, okay. Printf %d size of k by is equal to I plus j. Okay, and lastly printf %d k. This is my code, sir. What will be the output of the code if I execute this one? Try this one, guys. Yes. Very simple. We should not take this much time to give the answer. Very, very simple. No. Two printf statement is there, na? So two output will come. How many printf statement is there? Two printf statement is there. So how many output will come? Two output will come. No, not 13. Not 13. Observe here carefully. When the program will be compiled, is size of operator is there? Yes, there. What size of operator will do? Sir, it will be considering here size of how many operand is there? K is there, I is there, J is there. Everyone is of what type? Everyone is of int type. So at the time of compilation, he will return here 4. Return means giving here 4. This line, sir, here size of operator is not there. So when it will be executed at runtime only. Only size of operator, whatever is there, that will be executed at compilation time. Except this, everything is at runtime. Yes, Chetan, correct. Sir, here it is 4 and this is K. K value is what? 15. Do you think that this fellow will get the chance of execution? No. Why? Because at runtime, this thing will not come into the picture. Na, sir. At compilation time, this part will work and it will give me 4. So my program will run. This part will never be visible, sir. This part will never be visible. So even it is there in the coding, it will never be executed. It will never get the chance of execution. So that is why in this case, we will get the output as 4 and 15 respectively. Okay, na? Very easy, sir. If you learn this working principle of the size of operator perfectly, it is very, very easy, sir. Next and after that, let us take one more example with respect to size of operator. See here, suppose I'm writing here printf double quotation %d. Here I'm writing size of, and here I'm writing printf. Here I'm writing printf. After writing printf, here I'm writing something like learning C is fun. Learning C is fun. This is my code, sir. In this code, what will be the output? What output we will get it, sir, here? When the code will compile, what output we will get? Okay, let me help you in this case. See, guys, printf is a function. Printf is a function. We are generally having two type of function. One is called built-in function, or some people call it as predefined function. Predefined function. Another one is known as user-defined function. User-defined function. Printf function, but actual function is of two types, sir. Built-in function as well as user-defined function. So what is built-in function, sir? The function that comes along with your programming language API. The function that comes along with your C compiler. That is nothing but is the predefined function. Example of predefined function: printf, scanf, next sqrt, next pow function, etc. These are considered as a built-in or predefined function. Similarly, user-defined function means sometimes they call it as programmer-defined function also. Programmer-defined function also. Example of programmer-defined function: suppose you are writing M1 function, fact function, M2 function, right? Prime function. These are not inbuilt. You have to define those functions. You have to write the logic for those functions, right? That is called user-defined function. Now, printf function, how it looks like, sir? How the printf function looks like? If you want to see how the printf function looks like, very simple here. You see here, this is how the printf function looks like. This is how the printf function looks like. This is how the actual printf function looks like. Now, if you make a careful observation here, guys, see the return type, this particular portion, this is not required, just concentrate on this part. This particular portion is called return type. What it is called, guys? Return type. This is what it's known. This is known as name of the function. This part is known as what? Arguments. This is known as arguments, right? You know, there is a long stories there. If I try to, explain this part now, why 3 dot, what is this pointer? Currently, we will not enter into that much details. 3 dot means it is stands for variable args, var args. That means printf function can take any number of argument now, guys. Sometimes you write percentile d a b. Sometimes you write percentile d a comma b comma c. Sometimes you only write printf hello world. So sometimes it is taking 0 argument, 1 argument, 2 argument, 3 argument, something like that. Not 0, 1 argument, 2 argument, 3 argument, something like that. It can take any number of arguments. For denoting that part, it is having these 3 dots. It indicates var args. Var arg is a separate story. Currently, we are not going to enter there. Here, the interesting and important point is that return type of the printf function. Return type of the printf function. What is that? Int. Not only that, if you want to see the return type of scanf function, return type of scanf function is also int. You see, return type of the scanf function, it is also integers. So these 2 points you have to remember, because there are so many cases will come where this knowledge will be needed. What is the return type of printf function and scanf function? Return type of printf function and scanf function is integer. This much information is enough. What is there inside it as the argument, how it is, what is this thing, not required. Just to the return type, we must have the awareness. Now you come here, guys. When this line will try to execute, what will happen? At the time of compilation, guys, at the time of compilation, when the program will be compiling mode, that means at the time of compilation, stage, this line will be replaced by something. By what, sir? Sizeof. Here it is the function. Function calling takes place when? At runtime. But currently where we are? At the compilation time. We have not reached to the execution mode yet. We are just compiling the code and we want to know what is going to happen. So at the compilation time, function will not execute. But at the compilation time, sizeof operator will definitely execute. What he will do? He will check that array, is there any data type is there? No, not there. Is it an expression to evaluate? No, not there. But then how I will get the size of a function? That is what now the compiler is getting confused. Compiler, you don't require to be confused. Why? Because printf function return type is integer. So whatever printf will return, that will definitely be integer value. Return means, I already said to you guys, return means you have to remember giving. Giving is nothing but is returning. So whatever printf function will return, here always you are going to get an integer value. Here always you are getting an integer value. So if you are always getting an integer value here, because printf function return type integer, na? So always you are going to get an integer value here. So the filling of size of will be what? Oh, I have to calculate the size of integer only. And size of integer is what? Already we know that. What is that? 4. So this printf statement, compilation done, guys. Compilation done. Now when the program will go to the execution mode, it will simply see printf %d4. It will simply see printf %d4. Then what will be the output, sir? 4 only. Compilation and run. See this, guys. Only the output is going to come as 4. Sir, if I remove the size of operator, then what will happen? Okay, first let me copy up to this as per the discussion. Okay. See, guys, suppose if I remove the size of operator, what will happen? Then is it going, any compilation activity is going to come here? Means anything is going to work at the compilation time here? No. So at runtime, what will happen? See, one function, printf itself is a function. Inside this, another printf function. Inside this, another printf function. This type of function callings are known as nested function. This type of function callings are known as nested function. Function calling is working as an argument inside another function. These type of things are known as nested functions. You have to remember, in case of the nested function, the inner function works first. In case of the nested function, which works first, guys? The inner function works first, sir. Now, here, the inner function is a printf statement only. What is that printf statement? Learning C is a fun. So that means what is going to print? This fellow is going to print. Learning C is a fun. After printing, he will return how many characters is successfully printed in the console. Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Space have to be counted. 10, 11, 12, 13, 14, 15, 16, 17. 17 characters I'm going to print into the console. Now it is going to return 17 here. First it will print the value learning C is fun, and after that it is going to return 17 here. Return means already I told you, giving here. This place will get what value? 17. Then what is the output we are going to get? Learning C is fun followed by 17. Learning C is fun followed by 17. This is nothing but known as nested function calling, guys. This is nothing but known as nested function calling. Are you getting the clarity, students? Everyone is understanding whatever clarity I'm providing with respect to this? Yeah. Next, and after that, let us go for next one. So yesterday we have learned about the comma operator, right? Let me verify. Really you have learned the comma operator or not? Let's, for example, I'm giving you int I is equal to some values I'm assigning here, 10, 20, 30. Int I is equal to 10, 20, 30. Printf %d I. Yesterday I discussed about the comma operator story. Comma can work as an operator, comma can work as a separator. So here you people have to tell that if I write this code, what will happen, sir? What will be the output in this case? What will be the output in this case? Yeah, most of you are thinking, sir, the output will be 30 because you told in the last class, na sir, that comma operator working principle is the rightmost value will be returned. No, first you ask yourself, is comma is going to play the role of operator here? Isn't it a declarative statement? Isn't it a declarative statement? Yes. Once it is a declarative statement, is comma is going to play the role of operator? No. Where comma play the role of operator? Sir, except declarative statement and except function argument everywhere. So first of all, isn't it it's a declarative statement? Yes. Sir, in the declarative statement, up to this no problem. Up to this no problem. I is a variable assigned to 10. After that 20. But where 20 will be assigned? Where 20 will be given, guys? Where is the variable to get the 20? Because if it is an operator, no problem, sir. Rightmost value will be assigned to I, no problem. But it's not on, its comma is not going to play as the operator here because it's a declarative statement. It is a declarative statement here. Now the question will be raised, up to this no problem. Variable I declared, assigned to 10. Now what about this? Compiler will think this fellow is a declarative statement fellow. Means like the way you will write now int I, j, like that. He will think, he will treat them like a, like them as a variable declaration. But it's not a variable declaration actually, because 20 is a constant. 20 is a constant. Compiler get confused. If you confuse compiler, compiler will give error. If you make confuse compiler, compiler will give error. See this? This is the problem. What it is telling? It is telling expected identifier or first bracket open before numeric constant. Means what they are asking? They are asking that either instead of using a constant, You use some identifier like J, use some identifier like K, I will not give the error. This is one possibility, no error. Other possibility is before the numeric constant, put a first bracket open, first bracket close. That means keep them inside the first bracket open, first bracket close. If you keep it in this fashion, then also I'm not going to give any error. See first, what is the output, I will let you know, but see first, error gone. So these are the two suggestions by the compiler. I followed that two suggestions and I'm getting rid of the compilation time error. So as per this coding is concerned, what is the output, guys? No output, sir. This code will suffer from the compilation error. This code is going to suffer from compilation error. Okay. Now as per the compiler suggestion, what I am doing, guys, I'm putting a bracket here. And after putting the bracket, now I am asking, tell me what will be the value this time. Tell me what is the value this time. Now I think you will make it correct. Now there is no doubt about that, sir. What will happen? Int I is equal to, from here some value will come. First of all, is it a declarative statement here? Is the total value is the declarative statement? Yes, total value is declarative statement, but I'm not using comma in the declarative statement. I'm using the comma inside it. Not as a part of declarative statement. As a part of declarative statement means like I, comma, J, comma, K. Here the comma is a separator in a declarative statement like this, like this. After this, if I give a comma, that comma is a part of declarative statement. But here I'm using the comma here inside the first bracket open, first bracket close. So it's not a declarative statement part, sir. It is, the entire thing is a declarative, but here this is not like a declarative part. From here some value will come. Here comma will play the role of operator. And if comma plays the role of operator, you know the working principle now, guys. Left to right it works. Rightmost value will be given. What is the rightmost value? 30. Now if I go for compilation and run, the I value will be given me as 30. Understanding or not, guys? Comma operator. Now another variation, let me give it to you. So this is one more variation. Suppose for example, you declared I here, only the variable I. Next line you are writing I is equal to, this one you will make it correct, 10, 20, 30. 10, 20, 30. And I'm printing the I value. Tell me, guys, what will happen? What will happen in this case? What is your suggestion in this case? What output we should get? Any suggestion? See here, very simple. This is a declarative statement. Done. Next and after that, I is equal to 10, comma 20, comma 30. How many operator is there, guys? 2. Equal to and comma. Who is having high precedence? Equal to. Simple. Simple, sir. 10 will be given to I. Sir, compilation error will not come? No, not come. Why? Sir, in the first example it came, na? Sir, in this example it came. Here it came. Why not it will come here? There is a difference between these two. Observe carefully. This fellow and this fellow are not same. This is in a declarative statement. In a declarative statement, you must have a variable. In a declarative statement, you must have a variable which you can assign with a value. So it is definitely a declarative statement where compiler is searching for identifier, variable name, not getting. That's why becoming furious and giving you the error. But that thing is not happening here because it is not a declarative statement, sir. Is it an executable statement? It is an executable statement. Here operator precedence associativity will come into the picture. And as per that, assignment operator is having high precedence than comma. 10 will be given to I. After that, what happens? Just two values, 20, 30 can be there. Can't I write a C program like this, guys? Just I wrote 20, 30. Nothing else. No variable, nothing. Just I wrote a C program like this, 20, 30. You ask the compiler to compile the code. Let's see what is happening. No error, no warning. Possible, sir. Possible. Even you can write 20 and 30. What will happen? It will not be used in my program. Because to use it in my program, I need a variable to capture the value. So that's why it is not used in my program. But in a declarative statement, sir, can I write like this? Can I write like this, sir? Int 10, 20, 30. Is it possible to write, guys? Is it possible to write? Can you declare like this int 10, 20, 30? No. Declarative statement means some identifier, some variable should come into the picture. Now you go for execution, compile, definitely error will come. Tell me, students, getting the clarity? Any doubt, guys? Confirm once in the chat box. Understanding? Understanding, guys? Respond in the chat box. Are you getting the clarity? Yeah, very good. Next and after that. So today, mainly we focus in learning the size of operator. Now, let us assume I'm writing another code here. Int I is equal to 30. Int I is equal to 30. Printf %d. Here I'm writing ++i followed by ++. Tell me, students, what is the answer we are going to get here? What is the answer we are going to get here? I is equal to 30 ++i ++. Yes, most of you are thinking that, sir, it will be 31. Now you observe here carefully. In the last session, while learning this ++ operator, somewhere we mentioned that ++ operator or minus operator, they cannot be applicable to a constant. They are applicable to a variable. ++ operator or minus operator, whether it is acting as a pre-increment or post-increment, it is applicable only to variable, but not to a constant. It is applicable only to variables, but not to constant or expression. Not to constant or expression. Sir, what does it mean, not to constant or expression? First of all, let me tell you what is meant by not to constant. You observe here ++i, and you made it bracket. We know now precedence and associativity rule. As per the precedence and associativity rule, who is having high precedence? First bracket open, first bracket close. As a part of that first bracket open, first bracket close, now what will happen? This line will become something like this, guys. It will be becoming something like this. Printf %d. This fellow will work fast, and it will make it like 31 ++. Tell me, guys, can we have 31 ++? Can we write a constant ++? Is it possible to have this constant ++? No, sir. Why? Because if constant ++ is allowed, 31 ++ meaning will become 31 is equal to 31 + 1. But do you think 31 is equal to 31 + 1 is possible? No, not possible, sir. Then immediately what will happen? Sir, compilation error will come into the picture. Execute, compile. See, guys, lvalue required. Already in the last session, somewhere we discussed lvalue required. What does it mean? Lvalue required error will come into the picture. Sir, you said that increment or decrement, that is post or pre-increment, post-increment, pre-decrement, post-decrement, they are only applicable to variables but not to constant. Now you understand why I said that it is not to constant. Sir, you also said that it is not applicable to expression. Can you give the proof, sir? It is not applicable for constant. Yes. See here, guys. Suppose, for example, let me copy this code. Suppose, for example, here I am having two variables. A is equal to 5, B is equal to 6. And suppose I'm writing something like this, guys. plus plus a plus b, plus plus a plus b. Think a bit, guys. What will be the output in this case? What will be the output in this case? Tell me, students. What will be the output in this case? Anyone there who is thinking, sir, the output will become 12? No, good. Who is that? Chetan. Very good. Sir, it will be error. Why? Sir, first bracket open, first bracket close means this fellow will work first. Once this fellow will work, na sir, a plus b means 5 plus 6, 11. And now the expression will become what? Sir, the expression will become plus plus 11. Plus plus 11, guys. Can we have plus plus 11? Sir, if you say plus plus 11 is possible now, I will think 11 is equal to 11 plus 1. And I will think 11 is equal to 12. Total mathematics will be in danger, guys. So not possible. What will happen? Again, you are trying to confuse compiler, na? Compiler will give you error. Execute, compile. See, same thing. L value required. Understanding the operators, how it works, guys. All the possible permutation and combination I'm bringing into the picture to give you the more clarity with respect to different operators, right? Let us go for one more example. Okay. So before that, let me copy this one. See, guys, int I is equal to, I'm taking here some variable. What is that, sir? 39 or say 40. This is known as right shift. What is this is known as? This operator is known as right shift. So we are having bitwise operator. Under the bitwise operator, we are having left shift operator, right shift operator. So many shift operator we are having, left shift and right shift. And other than this, we are having bitwise OR operator, bitwise XOR operator, and bitwise AND operator. Why they are called bitwise operator? It is as because they work on bits. That's why they are called bitwise operator, or let it be bitwise operator. Maybe I will discuss tomorrow. Whatever times are there, not possible. Let's take a different one. Suppose I'm taking int x comma y is equal to 5 and z is equal to 5. And here I'm having one statement. X is equal to y is equal to z. Printf %d z. Can you tell me, guys, what value of z will be coming here as output? What value of z will be coming here as output? Sorry, forget about z, let it be x. What values of x will be coming here as output? Anyone there who can tell me, sir, what will be the output of x here? What value will come here? Very good. Sir, the answer will be 1. Why? Because what is this operator, guys? Sir, this operator is known as assignment operator. Already we know that assignment operator is having second last level precedence. Assignment operator is having second last level precedence. Here, what is the operator? It is relational operator. So equal to operator is there, equal to is also there. What is the difference? Sir, this is assignment operator. This is assignment operator. And this is comes under relational operator. 6 relational operator we are having now. This comes under relational operator. Now, who is having high precedence compared to this? So relational operator is having high precedence. So I wrote relational operator first. Relational operator, whenever it works, relational operator, whenever it works, you know that it gives us what? 0 or 1. Gives us means it returns. It provides what value? 0 or 1. Now you see, y is equal to z. This fellow will execute first as per the precedence associativity rule. So is 5 is equal to 5? Is 5 is equal to 5? What is the answer? Yes, 1 is the answer because it's a true value. that true value in the form of 1, that true value in the form of 1 will given to x, will given to x. And now whenever I will print the value, sir, 1 will be printed. Execute, compile and run. 1 is come into the picture. So this is all about, you know, guys, we are completing here. We are completing almost most of the operators. So bitwise operators are pending, left shifting, right shifting, those operators are pending. So mostly we completed logical operator, assignment operator, increment, decrement operator, we completed. Special operator, under special operator, how many we completed till now? We completed a comma operator and size of operator. There are still some more special operators are there, which I will bring into the picture at the time of pointer discussion, right? Tomorrow, mostly we will spend time in understanding the conditional operator. Yet another very important operator is there, conditional operator and bitwise operator. Tomorrow, this will be our target to focus. This conditional operator and bitwise operator to understand. And operator precedence and associativity, you know that. Every day it comes into the picture. Every day operator precedence associativity come into the picture. And evaluation of expression, what we do. Every time, every example, we are doing evaluation of expression only. No? Okay, that's it, guys. Hope you enjoyed the session and you got the clarity of whatever we discussed, right? Yeah, thank you, guys.